Statics is basically concerned with the equilibrium of the body. That is at rest or it moves with constant velocity. It is not always at rest. We do not we have not dealt with only things which are at rest. We have also dealt with things which actually moves, but move with a constant velocity. Okay. Now here, statics is basically what? It deals with statics is basically considers with the concerned basically concerned with equilibrium. It is concerned with equilibrium of body, which is either at rest or moves with constant velocity. Okay, so you cannot say in statics you are basically analyzing or dealing with objects which are only at rest. If things are only at rest, what are you going to analyze? What are you going to deal with? But from rest, when they start moving with a constant velocity, then and under the influence of the equilibrium of the body, you start analyzing it. Then in that setup of conditions, you say that it is static. Okay, and it is basically part of what? It is a part of engineering mechanics. As you have already seen now, mechanics means what? Either state of rest or in the motion when it is subjected to what? Any action of forces. This was regarding your statics. Now, here, with regard to the statics, we have already understood that what actually static is. Now, how is it different from dynamics? What is dynamics actually? What does dynamics mean? Now, from the already known definition of statics, can anybody tell me what can be, how can this dynamics be different from what statics? Does anybody have any idea? Here, this dynamics, it basically deals with what? It deals with accelerating motion of the body. It deals with accelerating motion of the body. And statics deals with what? Statics deals with those objects which are either at rest or are actually moving with constant velocity. And dynamics deals with accelerating motion of the body. Okay, dynamics is absolutely different, and it is actually combination of uh, the things that we already have in statics, plus there are some more equations that get added up due to this accelerating motion. Okay, due to this accelerating motion. Now you will get a clear picture of this once we move ahead. Now this dynamics itself is basically divided into two more things, two more parts, and that is firstly kinematics and secondly kinetics. Kinematics and kinetics. Now, what does kinematics mean and what does kinetics mean? Here, kinematics basically is kinematics primarily treats only the geometric aspect of the motion. It deals with what? It deals with geometric aspect of motion. Kinematics means geometric aspect of the motion. And kinetics basically is it is analysis of force causing the motion. It is analysis of force causing motion. Now, with regard to better understanding of both kinematics, as I have already mentioned, it is what geometric aspect of the motion. Now, if something is moving, it may be in a straight path, it may be in a circular path. If a particle is actually moving, here the kinematics deals with in which path or the all the geometric aspects of that motion. Kinematics actually deals with that, and kinetics deals with the force. Now, if we have a particle, until and unless some force is not applied to it, it will not move. It will actually remain stationary, right? It is not going to move anywhere until and unless there isn't any force which is basically driving it to move or take a different path. Okay. Now, broadly, kinematics, it is basically a study of the description of the motion. It is actually study of the description of the motion. Now, what does that again mean? Study of the description of motion. Now, here I will try to make you understand what what kinematics actually deals with. Considering here, there is a consideration where we actually are checking the description of the motion, and that is basically including it includes what consideration of space and time. Definitely, if a particle is moving or any body is moving, it's moving in space, right? And we have to take care into consideration the time that actually it will take to travel any path, because we can have different paths in which a particle or a system of particle has to move. For example, let's say I'll give you an example here to understand it in a better way. Let's say when we go to university, can anybody tell me or let's assume that every one of you have to travel a distance of 30 kilometer to reach to university, IUST. Okay, and you say that I have to take a path wherein from I have to leave my house and I have to reach university. That means you have a defined path wherein which will take you to university, and the distance is let's say 30 kilometers. And then I ask you, how much time does it take you to reach to university? Okay, you for example say that it will take me 1 hour to reach to university, covering a distance of around covering a distance of 30 kilometers. Okay, covering a distance of 30 kilometers. And now at the same time, if I ask you what was your speed, can anybody tell me what is the speed? If I say you have to travel to 30 kilometers and the time taken is 1 hour. Okay, can anybody tell me? Sahil, can you unmute your mic?
Yes, sir.
Okay, can you tell me what is the speed now? What is your speed?
So distance travel divided by time taken. Distance is, you said,
Fine.
as 30, and the speed is 1 kilometer, so 30 per hour.
1 kilometer per hour.
Yeah.
Simple. Now all these, okay, fine, fine. I don't want to go into the calculations. What I want to know is all these parameters are actually kinematics. All the parameters that we discuss here are kinematics, right? The direction, the speed, and the sorry, distance and the time is actually your speed. That was your speed for reaching to university. That is 30 kilometers per hour. Is that the thing? Or
Yes,
when you
sir.
have to change it, when you simply have to change it to meter per second, you can have different units. And here now what we have discussed how far we have reached, and we have discussed how much time has taken to reach to this distance, right? These are two things which we have actually to discuss in kinematics. That means, firstly, what we discussed here: how far have we reached? How much time has this distance taken to cover? Thirdly, we could now calculate number of parameters, like we could calculate average speed, we could calculate normal instantaneous speed. We could One more important thing apart from this is now acceleration, right? uh, until now we described uh, simple distance and time, and we could calculate speed. And then now what we need to understand is acceleration. Acceleration is how quickly or how slowly have you speed up or slow down, right? That is what is called as acceleration, right? uh, can anybody add anything on acceleration? What is acceleration? Zarka, can you tell me what is acceleration?
Acceleration is basically the rate of change of velocity. We say the definition of it.
Apart from that definition, what do you understand by acceleration? Give me simple. If
As
if you
physical
have to,
significance.
yes, physical significance.
मतलब if we see मतलब कितनी तेजी से एक गाड़ी तेज तेज चल रही है अगर देखा जाए.
Okay, fine, good. Badi ul Kunan, can you unmute yourself? Roll number 57.
Yes, sir.
Can you add something in describing acceleration?
Um, yes, sir. It means कि अगर for example हमारे पास एक गाड़ी है और वो कुछ टाइम पीरियड लेंगे उसमें मूव कर रही है, हम देखेंगे कि उसकी जो मतलब वेलोसिटी है उसमें कितनी चेंज आ रही है, या तो वो कितनी इंक्रीज हो रही है या तो कितनी डिक्रीज हो रही है, या अगर कांस्टेंट रह रही है हर टाइम पीरियड में तो हम कह सकते हैं उसकी एक्सेलरेशन कांस्टेंट है, जीरो है.
Okay, good. Can you tell me one thing, Abdul Basit? Basit, unmute yourself. Basit, can you please unmute yourself? I guess he's not able to hear. Fiza Zahur, row number 62.
So,
Fiza Zahur, can you tell me if I start my car and
yes,
now I have to reach 0 to 60 kilometer per hour.
yes,
Okay,
sir.
can you tell me what does that mean? What is it? Is it a velocity? Is it acceleration? What is it?
So, 0 to 60 kilometers
per
in
hour.
some stipulated time, in for example, a minute or so. I have to reach
Hmm.
from 0 to 60 kilometer in 1 minute.
So
So
we are
what is it?
there is a change in velocity. It's accelerating. We are accelerating.
We are accelerating. And
Yes,
now
sir.
that when I have to from 60 kilometer per hour to I have to stop my car. I'll apply brakes, and
Yes, sir.
now my car will come from 60 kilometer to 0 kilometer because I'm stopping it. Now what is that?
Hmm. Sir, deceleration.
That is
Sir,
deceleration. Good.
yes,
That
sir.
is that is actually negative acceleration, which is also
Yes, a
called as
negative.
okay. Good. Chale, you can mute yourself. So now here we were actually talking about kinematics, right? So what we have to deal with how far when we talk about this example that I have already given, that how far and what else was there? How much time? And then we talked about acceleration. And when we do not have constant speed, right? We can say when we do not have any constant speed because we are accelerating, we are decelerating. It's not that we can say that I have a constant speed throughout, which we have called as a velocity. Simple. Now, because either we are accelerating or we are decelerating. So we have here discussed three things. We have discussed a uh, we have discussed displacement. Can anybody tell me what is displacement? What is the difference between displacement and velocity? We talked about velocity and thirdly acceleration. Okay, you that Haris Rashid, roll number 5. Can you unmute yourself? Haris Rashid, are you there? Can you unmute yourself? Hazik, roll number 25. Roll number 25, are you there? Hazik. Whosoever is not replying back, I guess they are actually not present there, and I am marking them. So please make sure that you reply. Roll number 47. Roll number 47. Okay, fine. Zarka, are you able to hear me?
Yes, sir. Yes, sir.
So now here we talked about what? We talked about displacement. Okay, and we talked about velocity
And acceleration.
and acceleration. Now all these things, what are they describing actually? They are describing motion. They are describing motion. That is why we call all of them as kinematics. And here, when we talk about kinetics now, kinetics, as I have already said, what is kinetics? It is basically what? It is the study of forces. It is what? It is study of forces causing the motion. it is study of forces which are actually causing the motion. And the study of motion, the geometrical consideration, the geometrical aspects, wherein the primary things are your displacement, velocity, acceleration, deceleration, and so on and so forth, are actually called as kinematics. Okay, this motion related, all the details are actually called as, they are called as kinematics, right? And force is actually called as kinetics. Kinematics is geometrical consideration, geometrical aspects of the motion, that is called as kinematics. And as we already know, this motion we can easily see by our naked eyes that this motion is actually happening, but we cannot see from our naked eyes this force. Can we see any force? We cannot see actually the force, but motion is always visible to us. Motion, even when we have very minute motion, we can see that also under high resolution cameras. We can capture that motion. But when the force, when we are applying any force, whether that be any sort of force, that be in the form of torque, in the form of simple power, in the form of momentum, in the form of work, uh, we can just apply it. We can see the magnitude, but we cannot see when it is getting applied and how is it. Whereas in the case of the motion, we can see the geometric path. We can simply see that path, right? So here, when we talk about kinematics, now we have already many things uh, that are basically basically dealt with the motion. That is, firstly, what we have seen. We have seen distances are there in kinematics. What else we have seen? Displacement, as I have already mentioned that. We have seen speed, we have seen velocity are the measures. These are basically kinematic measures. These are measures. We have seen velocity and we have seen acceleration or deceleration. And in kinetics, what is there in kinetics? Kinetics will be simply force. Kinetics will be pressure. Kinetics will be work. Kinetics will be momentum. Kinetics will be torque. Kinetics will be power, and so on and so forth. Because we have a number of these forces which we can actually apply on anybody, which we can apply on anybody. So again, here we will be discussing about various types of displacement. For example, if we talk about, again, if we talk about displacement, what are the different types of displacement that can happen? Can anybody tell me? Displacement can, as per our knowledge, it can be either linear displacement, it can be linear displacement, or it could be it could be angular displacement. When you are just twisting anything, there is a displacement, and in that case, that twist actually gives the displacement in the form of angle. We say that this object has moved 30 degree, or it has moved 40 degree, it has moved 50 degree. And whereas in the case of the linear displacement, we say this object has moved 5 meters from its actual position, or it has moved 10 meters, it has moved a kilometer, and so on and so forth. As in the case of angular displacement, we simply say it is what? It is simply the angle that basically defines the displacement. And now, in case of the linear displacement, we say that we usually correlate them with time. That means we say that this object has moved this amount of distance per second, per minute, or it has moved 1 kilometer per hour. And in the same sense, we say when we talk about angular displacement, we say this object has moved 30 degree. When we talk about displacement, it has moved uh, this amount of degrees per second, or that depends, the units depends upon you what you're taking. So here we will be having, in terms of displacement, we will be having two type of displacement, linear and angular. You already have a good understanding on that. Apart from this, now I hope you have understood what the uh, kinematics and what is kinetic. Kinematics is simply what? Study of or geometric, what we called as aspects of the motion, right? And kinetics is the study of the forces that are basically causing this motion. Okay. Now we actually usually have two types of motions. We have types of motions. One is called as rectilinear motion. Sorry, this is called as rectilinear kinematics. We can simply define it into kinematics. Can anybody tell me what is the opposite of this rectilinear now? What else can be there? And another
Curvilinear.
is very good, curvilinear. Curvilinear kinematics, or simple motion. Okay, now Zalka, can you tell me what is rectilinear motion or kinematics, and what is curvilinear kinematics or motion?
So, rectilinear motion is motion in a straight line, and curvilinear is like motion in angles, angular motion.
Or kind of a circular motion.
The circular motion.
Okay, good. Good enough. Okay, fine. Before we will go into the actual details of understanding this rectilinear and curvilinear motions, I would like to put some light here on the background actually, of this dynamics. As you have already understood, where actually the principles that we actually depend upon in order to analyze, dynamically analyze the structure. It was basically way back in 1500. It was actually given by Galileo. In 1564 till 1642, he has worked with regard to the dynamics of any particle, of any object, and he was the major contributor in the field of dynamics. He basically worked on falling bodies, or pendulums that actually dealt that actually was the concept behind that was actually the actual understanding of these natural phenomena dealt with the dynamics actually. And until then it was only the statics that the scientists were actually concerned of, but he gave certain contributions in dynamics. And the most significant dynamic contribution were actually after after him made by Isaac Newton, as you already have might have studied about him. Now, can you just tell me what did Isaac Newton give in or the era that he was actually discovering things, that is 42 to 1727. He gave three important fundamental laws of motion, right? And law of gravitational, universal gravitational attraction also, right? He gave and can anybody firstly tell me what were the three laws that Isaac Newton gave with regard to the law of motion, right? With regard to what I'm talking about, law of motion. When we talk about motion, we should certainly know who were the people actually behind the ancient concepts, behind the actual concepts of motion, and also gravitational attraction. Okay, fine. Tell me what were the three laws that actually Isaac Newton gave. Can anybody tell me that quickly? Don't waste time. Tell me quickly. What were the laws?
So Newton gave three laws of motion. So पहला वाला था कि if a body is at rest or is moving at a constant velocity, then it will remain so unless an external force is applied. दूसरा is rate of change of momentum is equivalent to rate of change of velocity with respect to time. एक second. And the third is every action has an equal and opposite reaction.
Okay, can anybody is any does anyone else want to add anything to this? Is it correct? Is it correct?
So second one, rate of change of momentum is proportional to force applied.
Okay, good. Anything else?
बाकी ठीक था.
Okay. Okay. Anyways, good enough. So these were the actually laws that Isaac Newton gave, and in order to understanding of this dynamics now, these three laws played a very important role. Basically, why do we want to analyze now dynamically? I mean, what made us to see what are the dynamic aspects of any motion? There were so many of problems actually in engineering field whose solution was not actually exact, and that solution required application of principle of dynamics in order to analyze those problems, right? In analyze those type of problems, we had to take into consideration the principles of dynamics. And usually this for example, when we say when we have to talk about the structural dynamics or structural design of any vehicle, when we have to talk about the design of any vehicle, do we take into consideration the dynamics, principle of dynamics? Yes, we have to. For example, and also in case of airplane, in case of airplane, we have to take into consideration the principle of dynamics. That also, when we talk about automobiles, whether that be cars or aeroplanes, it requires consideration of motion to which it is subjected. It does not have static motion, right? It never has. Neither automobiles has a static motion, nor aeroplanes. They have a dynamic motion actually. So when we are designing them, we have to take the dynamic aspects into consideration. And again, apart from this automobiles, we have different types of motors, we have different types of pumps or tools that we have or in general we have different type of machinery wherein we need to take principle of dynamics into consideration. And again, when we talk about prediction of motion of satellites, artificial satellites I'm talking about, when we have to predict the motion, what we take dynamics into consideration. We cannot take statics, we cannot. And further, when you might have dealt with projectiles and spacecrafts are also, there is a theory of dynamics which need to be applied with regard to the principle of dynamics. Okay, now we need to develop a sense wherein we can at least take into consideration the primary principles, primary considerations while we talk about dynamics. Then dynamics, later on you will have to study various courses with regard to dynamics. When you talk about earthquake forces or earthquake resistant design of structures, that will be your course in, I guess, seventh semester or so, wherein we talk about this dynamics, because dynamics is absolutely in civil engineering, it is absolutely the earthquake forces or the earthquake resistant designs that we actually take into consideration all these forces. And then when we here I'll come back to the two types of kinematic that is rectilinear and curvilinear, which we have already discussed. Firstly, it is rectilinear. Rectilinear kinematics. And in rectilinear kinematics, we will actually study the dynamics. Here it is dynamics, right? Talking about dynamics. Actually, sorry, kinematics and kinetics are two subcategories of dynamics, not statics. We are not studying statics. So, rectilinear kinematics here is like discussing the particle that move along a straight line path. Particle, we are only talking about particle that move along straight line path. Now, I talked about particle. We'll have to in this course we will have to deal with one that is particle. Then we have to also deal with system of particle. Then we will go to rigid bodies. We'll go to rigid bodies. We have three types of studies that we have to do. One is a particle, a single particle, and then secondly a system of particles, and thirdly rigid bodies. Okay, now can you tell, can any one of you give me a broad picture of particle? What is particle? Why do we talk about particle? In order to here in order to better understand, we'll start with the particle. Now, when we talk about any particle, we say let's say this is a particle. Why and why do we define it a particle? We say it has a mass. This particle has a mass, but at the same time, we say that it has a negligible size and shape. We define particle as, in terms of its physical appearance, we say it has a mass, replicates the mass, but at the same time, we say that it has very minute, very small amount of size, and its shape is also we cannot give the proper definition of its shape as well. So here, what we do, we limit application to those objects that have dimensions. When we talk about particle, what are we doing? We must limit here the application to those objects that have dimensions, that are of no consequences while we are basically analyzing in motion. In such considerations, we talk it as a we consider it as a particle. And mostly in many cases we will be interested in here bodies of finite size. Bodies of finite size when we talk about particle. For example, here what are the real pictures, what are the real things that we actually can consider as a particle. Now I say, as I have given the examples of automobiles or rockets. Can anybody tell me, can we consider them as a particle? Can we consider them as a particle? When I say that this is the path and my car ha- was at point A, and at time T it reached at distance B. Can I consider it as a particle, or I have to consider it in some different form?
No, you cannot consider a car as a particle.
I cannot. Can anybody please add on this?
So क्योंकि quantum physics का particle पे आता है ना ये concept.
So if distance is much more than the dimensions of the body, then we can consider it as a particle.
Yes, good. It depends upon the distance as well. Not only the distance. It depends upon the other dimensions that you are actually. For example, we're talking about a car has moved 30 kilometers. Or when we talk about rockets, what do you say, Zarka, when I talk about a rocket? Can I consider that rocket as a particle?
So I was thinking with the quantum particle के साथ quantum physics का concept.
Talking about, listen, I'm talking about dynamics.
Okay.
To correlate things, I'm talking about kinematics, I'm talking about kinetics, I'm talking about motion, I'm talking about force. Now I have to take into consideration the dynamic aspect. And at the same time, when I am talking about the dynamic aspect of this, that means we're correlating it with actually motion. And with the finite size of, let's say, cars, and finite of these rockets or any projectiles, when you might have studied projectiles as well, and what do you consider there? You consider there as a particle. You have a finite size. Here, what we actually consider these type of things, or you have a ship in the ocean. When you have a big, let's say a big ship in the ocean, and you look towards the ocean, and you find a very small point somewhere in the middle of the ocean, with regard to the surrounding as well, surrounding dimensions. If you have any finite particle, and now that you are dealing with the dynamics, you are dealing with the motion, you are dealing with kinematics, kinetics, it is actually the motion, it is actually the path, it's actually the other displacements which you are actually concerned. In such cases, here all these things will be considered as a particle, as long as the motion is characterized by the motion of its mass center and any other rotation of the body. Here is actually basically, if the body is itself getting rotated somewhat, we neglect that. We do not say, for example, if you have a particle, do not give the actual dynamics or the the actual self rotations into consideration. You neglect that actually, because that can be there as well. But here we actually neglect those, and only concerned about what we are only concerned about the positions. Here, in case of kinematics, or what we called as linear kinematics, the kinematics of a particle is basically characterized by finding few things. What is, and that is basically at any given instant, the particle position. Firstly, we are concerned with particle position. We are concerned with velocity, and we are concerned with acceleration. We are concerned with three types, three different things, and those three different things, what they are: particle position. Where is that positioned? What is the velocity? And what had been the acceleration? What will be the things that we actually deal in what rectilinear kinematics? Okay. So I guess for today's lecture, this is enough, and we will go into a deeper aspect of understanding this dynamics now in our next class. And in the meanwhile, just go through your books and try to grasp all these things, because this will help you in future when you have to deal with the dynamics of structures, when you have to deal with the earthquake raised designs, and wherein you have to understand the dynamics. So it will help you out there. Yeah. Okay, fine. I guess this is enough for today. Sahil, are you there?
Yes, I'm here.
Okay, Sahil, just do one thing. Now that you have the what we call as all the attendance with you, and get the attendance from the Muzaffar sir as well. And have you tabulated in some Excel form, or you have just handwritten it?
No, so I have not handwritten it yet. I just have the screenshots on my phone.
Okay, fine. That means you need not to handwrite it. Make an Excel sheet.
So, but I told you I have lost some screenshots that I provided to Muzaffar sir.
But you are talking about the classes which Muzaffar sir has conducted, or mine also.
No, sir, Muzaffar sir. Muzaffar sir
Fine,
has
whatever
conducted.
you have, rest I'll get from him. Just keep a blank on those dates in which you're not able to fill, in which you don't have. I'll get that myself, because he might have in his Zoom account. We'll try to get it from there. But rest of them, please give me the details. And okay,
So,
fine, just give
handwritten
me.
details.
Huh?
So, handwritten details. I provided
No,
them.
don't go handwritten. That will be complicated. You might be having the list of students in soft copy format. Just paste that in an Excel sheet, and at the same time, you have these screenshots. Mark those attendances on the Excel sheet. By this, you will learn how to do things also, and
Okay, sir.
mark those attendances on the particular dates. That's it, and then send to me all the attendances.
Okay, sir.
Fine. And
Right
tell
from
me
the
one more
begin.
thing.
Right from the beginning, huh?
Yes, all the classes.
Okay, sir.
I don't think you don't have to mark for more than 20 students who are usually a regular
Yes, sir. It varies. Approximately, it's 20 to 25.
That is it. Chalo, whatever is it, just give me that details.
Sure, sir.
And one more thing, what about, are you recording these lectures for your further study, or
Yes,
you
so
need not?
yes, sir.
Uh,
One of this, Bas says.
who is he
So
No,
maybe
sir,
that's
he's
Abdul
why
not.
Basit?
he.
No, the Abdul Basit is their roll number 24.
Yes, sir. He's maybe he's not able to talk because he's recording the lecture.
Okay, fine. Then after recording the lecture, I guess he has some issue. Why don't you unmute yourself, Abdul Basit? Okay, fine. Anyways, just tell him to record all those lectures, and then they can be there